Okay, so we've answered a couple questions on homework. Anybody have any other questions on their homework they want to go over? Or? Good? Okay. So we want to take the stuff we've been looking at one step further today. We want to look at something called integers. It's not as bad as you think, as long as you look at it right. To understand integers, we got to understand how the values work with our positive numbers. So if we have a number line set up, the first thing is to figure out how do we represent a number. So let's say I give you the number 7 here. How do I represent a 7 on the number line? Well, one way is we just put a dot at 7, which is a quick way to represent it, but it's not a very functional definition. I can't do much with it. If I want to do something with that 7, a more usable representation looks like this. I draw what's called a vector. A vector is just a fancy name for an arrow that starts at 0 and goes to that number. So there's my vector for 7. Starts at 0 and goes to 7. That vector is a operable representation. It's a usable, mechanical representation. So let's say I have 7 plus 2. My vector for 2 is going to look like that. Addition is just the operation of combining vectors. So to add these two numbers, I'm going to take the two vectors and I'll put them together. And now what I have here with the 7 and the 2 together is I have one long vector that goes from 0 to 9. 7 plus 2 is 9. Now, you guys could have done that without drawing out vectors. But the reason I did it that way is because now what if this is 7 plus a negative 2? Well, we need the vector for a negative 2. That's going to look like this. If I now take that vector, and I'm going to redraw it here so I can move it and leave a shadow. And I combine that with my vector for 7. That's going to come up here like that. And see, now it ends up at 5. 7 plus negative 2 is 5. So the vectors show us exactly what has to happen. Now, I don't expect you to draw out number lines every time you add with integers, with negative numbers. I don't. I certainly don't. But I do keep that picture in my mind as I do it. For example, if I have negative 12 plus 19, what I am thinking in the back of my mind is this. Here's 0. Negative 12, go right or left? Left is negative, right? That's negative 12. Plus 19, does that go the same direction or the opposite? Opposite. Is it longer or shorter? It's longer, so it goes past 0. It's into the positives. So this picture tells me two things. 1, my answer is in the positive side of 0. 2, the arrows go the opposite direction, so it's the difference in their length. The difference between 19 and 12 is 7. So it's a positive 7 is my answer. Now I'm going to define something called absolute value here. Absolute value has two different working definitions. One is the length of the vector. Two, distance from 0. They both give the same result. The absolute value of negative 12, well, how long is the vector for negative 12? 12 units long. Negative 12 is 12 units from 0. The symbol for absolute value, by the way, is these vertical lines. So the absolute value of 19 is 19. Now, some people say absolute value makes everything positive, and in some ways it kind of does, but that's not the definition of it. Absolute value is that length of the vector or the distance that value is from 0. So you're going to hear me say the length of the vector, the size of the vector. What I'm talking about is absolute value. So what if I have negative 11 plus 5? Same thing. Here's 0. Negative 11 goes which way, left or right? Left. Positive 5, same or opposite? Opposite. Longer or shorter? Shorter. So it doesn't matter if I get them drawn to scale. This picture does tell me I end up on the negative side of 0. My answer is negative. The arrows go in different directions again, so it's the difference between their lengths, the difference between their absolute values. So I'm going to take the bigger absolute value, which is 11, subtract the smaller absolute value, which is 5, gives me a 6. So my result is a negative 6. If I have a negative 52 plus a negative 39. Only when you're multiplying or dividing. Here's 0. Negative 52 goes this way. Negative 39, same or opposite? Same. So those both go in the same direction, so it tells me two things again. One, they're both going negative, so the answer is definitely negative. Both are going in the same direction, so their absolute values add together. The length of that vector is the two absolute values together. So it's 52 plus 39, which is 91. So it's a negative 91. What do you think? Not so bad? Not so horrible? So 127 plus a negative 318. So from 0, where do we go? Right or left? Right for 127. Negative 318, same or opposite? Opposite. Longer or shorter? Longer. So we're back in the 0 range. Arrows go the opposite direction, so we're going to subtract the absolute values. Which one's going to go first? The bigger one is the 318. Good. Minus 127. It's 191, right? So negative 191. What do you think? Not so horrible? Oh, we're going to do subtraction next. So let's look at 8 minus 3 for a second. Subtraction. If I were going to represent 8 minus 3 here, start out at 0, draw the vector for 8, and then I would go from 8 back to 5, because I know that 8 minus 3 is 5, right? If I look at that, this vector right here is the vector for negative 3. What I just did here looks an awful lot like 8 plus a negative 3. In fact, it is the picture. It is the vector representation of 8 plus a negative 3. Because subtraction, as we mentioned over the last couple days, subtraction is not its own operation. Subtraction is part of addition. It's a byproduct of addition. One of the definitions of subtraction is it's addition done in reverse. But the technical definition of this symbol right here, that symbol, the subtraction symbol, always works with the number that comes after it. Just like division works with the number that comes after it. Subtraction works with the number that comes after it. So minus 3 or subtract 3 means add the opposite of 3. Or add the opposite of whatever that next number is. So we're adding the opposite of 3 is a negative 3. So if we have 19 minus 7, that really means 19 plus a negative 7. Now, if those two numbers are positive, it's a lot easier for me to do just 19 minus 7 than 19 plus negative 7. So where this really only comes useful is if we have a negative number. So like say we have negative 23 minus 14. Well, that's what happens to the negative 23. It stays the same. Nothing happens to the first number. But minus 14 becomes plus a negative 14. So up here, we have a positive 19, negative 7 is shorter. So that tells us that's going to be a positive 12. Right? So on the positive side, the difference between 19 and 7 is 12. We knew that 19 minus 7 is 12. Down here, negative 23, negative 14 goes the same direction. That's a negative 37. The confusing part with subtraction comes when they look like this. The 18 does not change. But minus a negative 7 means add. The opposite of negative 7 is positive 7. Add a positive 7. So it's 18 plus 7, or just 25. We don't even need to draw out the vectors for that one. Even more confusing might be negative minus another negative. Negative 39 minus a negative 54. What's this become? The negative 39 stays negative 39, yep. And then? Yeah, subtracting a negative 54 is adding the opposite of negative 54, or adding a positive 54. So now to the vectors. Got negative 39. Positive 54 is the opposite direction, longer or shorter? Longer. So our answer is positive, and it's the difference between 54 and 39. I'll take the larger absolute value first, is 54, minus 39 is 15. So this is a positive 15. What do you think? Or have you guys try a few?
How would you write it in definition of subtraction? You said it was like
adding the opposite of the
adding the opposite. Okay.
adding the opposite of the following number. Try those three and you know it's correct. Okay, so the first one here becomes just 28 plus 38, which is 66. This one becomes negative 53 plus a negative 19, which is a negative 72. So here's a negative 37 plus a positive 41, which is positive 4. Anybody get all three of those right? Okay. Anybody have any questions on them? Okay. For multiplication, we're going to go back to definition we explored a little bit yesterday. Excuse me. Don't mean to yawn in your face. We said 5 times 3. Again, before we learned how to multiply, before we memorized our multiplication facts, how did we figure out the 5 times 3? Yeah, 5 plus 5 plus 5. 3 5s added together. So with that definition, makes perfect sense then to have negative 5 times 3. That's going to be 3 negative 5s added together. What's that come out to be? Negative 15. Fits what we've all been taught, right? A little bit trickier is this one. 5 times negative 3. Can I take 5 and add it together negative 3 times? No, I can't. That doesn't work. So what I have to do there is I have to use the property that in multiplication, if you're just multiplying two numbers, you can switch the order of the two numbers. It doesn't change the result. So I can make that negative 3 times 5. And now that's saying that I have 5 negative 3's added together. I'm adding negative 3 5 times. What's that come out to be? Negative 15. Somewhere along the line, you probably taught, of course, a positive times a positive is always a positive because that's what it is, right? But you're probably taught a negative times a positive is going to give you a negative. Yep. A positive times a negative is going to give you a negative. So positive times a positive gives you a positive always. Negative times a positive gives you a negative. Positive times a negative gives you a negative. What were you taught for a negative times a negative? It makes a positive. You were taught negative 5 times negative 3 better be a positive 15. So basically what you see here is if we're multiplying two numbers, if they're both positive or both negative, if they're both the same sign, the result is positive. If there's one of each, one positive, one negative, the result will be negative. I want to talk about this one here a little bit more, though. I have negative 5 times negative 3. That's saying either I take negative 5 and I add it together negative 3 times, or if I switch to order, saying I take negative 3 and add it together negative 5 times. Can I do either one of those? Say no. No. The definition of multiplication doesn't work here. A negative times a negative is not defined by the definition of multiplication. So how is it that we all know that it has to be a positive 15? Because you were always told two negatives multiply to make a positive. Why? Well, this actually happens a lot in math where our basic definitions break down and they don't work. So what we do is we look for a pattern in the examples that do work. For example, let's take our negative 5 times 3. That was negative 15. Now, to establish the pattern, what I have to do is I have to change one thing and see what else changes. So I'm going to keep the negative 5 the same here, but instead of multiplying by 3, I'm going to multiply by 2. What's my result? Negative 10. So I'm going to keep the negative 5. Now here I went from 3 down to 2. I'm going to go from 2 down to 1. What's my result? Negative 5. So let's look at my pattern. I started with negative 5 each time. Here I started with 3, I went down to 2, so I reduced that by 1. Went from 2 down to 1, so I reduced that by 1 again. Here I went from negative 15 to negative 10, I added 5. Went from negative 10 to negative 5, I added 5 again. So let's take the next step and see if this pattern continues. I'm going to keep this negative 5. What has to go here? 0. If I'm reducing by 1, 1 minus 1 is 0. Negative 5 times 0 is 0. Anything times 0 is 0. Did the pattern keep going here? Yeah, negative 5 plus 5 is 0. That pattern seems to be working. So let's assume that the pattern keeps going. So I keep that as a negative 5. If I reduce this by 1, I'm multiplying by negative 1. If I add 5 to 0, I get positive 5. Exactly. Negative 5 times negative 3 is 15, only because it continues this pattern. A negative times a negative is a positive, only because it continues all these patterns when we do them out. Like I said, that happens quite a bit in math. If you talk about powers and stuff like that, what's the power of 0 mean? Well, a power means you multiply something by itself a certain number of times. You multiply it by itself 0 times, what the heck does that mean? It doesn't make sense. We look for the pattern. We'll show you that when we talk about powers more. We'll show you what that pattern comes out to be. So, if I have 7 times a negative 5, what do I get? Negative 35. Negative 11 times a negative 8, what do I get? Positive 88. Good. Negative times negative is a positive. If I have negative 9 times 3, I get negative 27, yes. You'll see that the negatives don't affect the value at all, the absolute value. 7 times 5 is 35. 11 times 8 is 88. 9 times 3 is 27. All it affects is whether it's positive or negative.
So what if we did like negative 9 times the absolute value of negative 3?
Good question.
Would that turn into negative 9 times 3, the value of 3?
Yeah. We haven't talked about order of operations yet, but that absolute value symbol is called an enclosing symbol, which means you have to do whatever is inside of it first. Now, there's nothing to do inside of that symbol, so now you do the symbol itself. Yep, that's what it's going to be. Yep. So the absolute value of negative 3 is a positive 3. So you cannot combine anything that's inside that symbol with anything else until you've done the symbol. So it's just negative 9 times a positive 3, which is negative 27. Division. Not as bad as it sounds. Now, I'm going to make this just a touch confusing here at first because I want to define what division is. 18 divided by 6. We know that 18 divided by 6 is 3, right? What 18 divided by 6 is really asking is a multiplication question. Remember, so this is multiplication done in reverse. So if we reverse this process, what we're saying is blank times 6 equals 18. What times 6 equals 18? 3 times 6. So this has to be 3. So now we're going to do this considering our negatives in with it. So if I have a negative 24 divided by 3 equals blank. What that is asking is blank times 3 equals negative 24. Well, first of all, 24 is negative, right? To get a negative result of multiplication, I either have to have a positive times a negative or a negative times a positive. I have to have one of each. The 3 is already positive, so this number here has to be negative, whatever it is. Make sense? It's going to be a negative 8, because 8 times 3 is 24. So negative 8 times 3 is negative 24. So this is a negative 8. If I have 32 divided by negative 4, that is asking what times, I can't write today, what times a negative 4 equals 32. Now again, let's look at the signs first. The 32 is positive, right? To get a positive, there's only 2 ways. A positive times a positive. Well, that's not what's going on here because this is a negative 4. So it's got to be a negative times a negative. So this is negative 8. Negative 8 times negative 4 is a positive 32. So that has to be negative 8. If I have a negative 36 divided by a negative 9, What that is asking me is what number times a negative 9 equals negative 36. Again, let's look at the signs first. This is a negative 36. To get a negative result, I have to multiply one of each, right? Well, the 9's already negative, so this one has to be positive. What times 9 equals 36? 4. So that's a positive 4. So we look at what happened here. We get the exact same pattern we do with multiplication. A positive times the positive divided by a positive is, of course, positive, right? A negative divided by a negative is positive. If we have one of each, either a negative divided by a positive or a positive divided by a negative, the result is negative. So division follows the exact same rules as multiplication. So it's the only thing you have to remember with this addition or subtraction. First of all, you make it addition, and then you do the vectors. If it's multiplication or division, you just have to remember both positive or both negative, the result is positive. Now then, this is only multiplication or division. I see a lot of people that try to make the mistake you tried to do there, that, well, I'm adding two negatives, the two negatives make a positive. No, not when you're adding or subtracting, only when you're multiplying or dividing. So both positive or both negative is going to be a positive. If there's one of each, the result will be a negative. Okay, in your books, we're going to jump ahead a few pages here. On page 111, 1 through 39, the odds are dealing with negatives, adding negatives. Page 114, 1 through 35, the odd is dealing with subtracting integers. And on page 116, 1 through 39, the odd, and 51 through 79, the odd deal with multiplying and dividing the integers. So I'm cutting the lecture a little short today and giving you some extra work time because this is kind of a longer assignment. So I want you to get a good start on it.